Alright, so we're going to talk about two-way tables and marginal distributions. So if we have two categorical variables, we're going to look at them one at a time, but we're going to organize them in a way that we're looking at a row variable and a column variable. So here we have some data. We have the chance of getting rich as one of our variables right over here, and we have the gender right here. So females are this column, males are this column. Almost no chance of getting rich right there. Almost certain of getting rich right here. So what variables are described by this two-way table? It's the gender and the chance of getting rich. How many young adults were surveyed? There were 4,826 total. It's the total when we add up the chance of getting rich and the total when we add up the genders. Should add the same way. A marginal distribution looks at one of the categorical variables, and it counts that distribution among all individuals. So we often look at percents as opposed to counts, and that's really especially important if we're comparing groups of different sizes. The data can be real misleading if you're simply looking at a count as opposed to percent of the whole. So what we're going to do to examine our marginal distribution is we're going to calculate the distribution in percents of the row or column totals. And we'll look at how to do this in a second. And we're going to make a graph to display this distribution. So here's our table again. Let's look at the marginal distribution of chance of getting rich. So we're going to find what percent of the whole each of these values takes on. So almost no chance is 4%. We take the 194 total and divide by the 4,826, and so on down the line. And we can then create a bar graph that shows what percent of the whole fell into each one of these categories. And notice this is not taking into account male and female. It's simply looking at the chance of getting rich. So most people think that they have a 50-50 chance or better of getting rich. People pretty much have a good outlook on their future. So this marginal distribution tells us nothing about the relationship between the two variables. It looks at the totals. A conditional distribution describes the values among individuals who have a specific value of another variable. So now we're introducing this second variable. So to examine or compare the conditional distributions, we're going to select the rows and columns that we care about. We're going to use the data to calculate the conditional distribution of the rows and columns, and we're going to make a graph. We're going to use a side-by-side bar graph or a segmented bar graph to compare these distributions. And one thing we'll look at is how to actually create these by hand and using technology. One thing to know is the marginal distribution looks at the totals, whereas the conditional distribution is looking at the split apart data. So here we go. We're going to do a conditional distribution of the opinion in males, and we're going to examine the relationship between gender and opinion. So here's our conditional distribution. It's conditional because we're not using the totals anymore. We're only looking at males, which is a part of the whole. And there would be our conditional distribution, our bar graph. If we want to compare this to the female conditional distribution, we do the same thing but with the females. So 96 out of 2367. Notice the males, it's 98 out of 2459. Here divided by that. And now we can compare, and what you notice is that less females are thinking that, or we have a lesser percent of females thinking that we have a good chance or almost certain chance of being wealthy by the age of 30. This is what we mean by a segmented bar graph. So the first blue color down here is 4%. You can think of it as a parfait. It's got layers. So almost certain, good chance, 50-50 chance, some chance, almost no chance. So here's our 4%, Here's our 11.6%. Here's our 29.3. It's the total size of this band, of this colored band, that is that segment. So if we want to organize a statistical problem, there's a 4-step process that we can do. And it's something that we can generally use on a large variety of problems. We want to figure out what's the question you're trying to answer. If you can't answer that, you really can't start. Then we come up with a plan. How will you go about answering this question? What statistical techniques does this problem call for? And we're going to develop these as time goes on. Then we're going to do. We're going to make graphs and carry out calculations. That's the doing part. So we're going to figure out what we want to do. We're going to think about how we're going to do it. Then we're going to do it. And then we're going to give a conclusion. We're going to give the practical conclusion in the setting of the real world problem. We're going to take that data and give it meaning. We're not just going to give numbers. We're going to give what those numbers mean. So state, plan, do, conclude, 4-step process, and this really carries over into other areas of mathematics and science too. State, plan, do, conclude. And there is our section summary. There it all is in one shot. And if you have questions, please make sure that you ask, make sure you understand the vocabulary, and we're going to develop making these graphs and pictures and doing the calculations together in class now that you have an idea of what it is that we need to do.